The water supply for the high-pressure, or HP steam drum, comes from the HP discharge of the boiler feed pump. Discharge flow from the high-pressure stage of the boiler feed pump to the HP drum is controlled by a single or dual-flow valve arrangement located upstream of the HP economizer. Prior to starting up a power plant, the HRSG will be empty and the various sections need to be filled with water. To fill the HP drum, the boiler feed pump is used. Prior to starting the pump, all drain valves on the HRSG economizers and evaporators should be closed. And vent valves open to purge the air out of the system. The LP drum is also filled prior to starting the boiler feedwater pump by the condensate system, as the LP drum provides the suction flow to the feed pump. To start the pump, the recirculation valve should be 100% open and the downstream feedwater regulating valves closed. Once the pump is started, a minimum flow rate as determined by the pump manufacturer will be established through the boiler feed pump recirculation valve to keep the pump cool. Feed pump suction pressure is 60 to 100 psig. Pump discharge pressures range from 2,000 to 3,500 psig and recirculates back to the low-pressure drum. The recirculation valve will see cavitating pressure drop for its entire operating range. Once the feed pump operation is stabilized, the HP drum will be filled using the feedwater startup valve. The valve is sized to provide the flow rate required to fill the drum in the time specified by the plant designer. When the drum is empty, the pressure inside is atmospheric. The boiler feedwater pump will be at high discharge pressure, creating high differential pressure that can cause cavitation in the valve. The startup valve needs to be designed to eliminate cavitation damage. Once proper drum level is attained, the vents are closed, combustion turbine started, and pressure and temperature will start to build in the HRSG. The turbine bypass system will be placed into operation and feed water flow will start to increase. Once adequate pressure and temperature are attained, the steam turbine will be placed in service. As the load on the steam turbine is increased, the feedwater startup valve will continue to open to maintain level in the HP drum. If total flow is less than 30% of boiler feedwater pump capacity, the recirc valve will close proportionally as the startup valve is opened to maintain the minimum flow rate through the pump, which is the combined value of recirc flow plus feedwater flow. As the plant continues to increase load, the HP drum pressure will rise to operating pressure. During this transition, the differential pressure between the drum and feed pump will lower to a point where cavitation is no longer a factor, but increased feedwater flow is needed to meet the turbine's steam flow demand. An ideally sized regulating valve system will have the main feedwater regulator valve CV at about 20% open, equivalent to the CV of the startup valve at 80% open. As a rule of thumb, the feedwater valve should have an equal percentage trim installed to offset the performance characteristic curve of the feed pump. Once the flow to the HRSG is more than or equal to 30% maximum continuous rating, the recirc valve will go fully closed and operation will be on the main feedwater valve. The plant is now in normal operating mode. There are two ways in which feedwater regulator valve applications are configured. The first option is to use a two-valve system as previously discussed. The second option, and a very popular retrofit in existing plants using two valves for the feedwater system, is to install a single valve that will handle both the startup and normal operating conditions. When a single valve is used, a special characterized cage is required to prevent cavitation damage. The lower travels of the cage use anti-cavitation trim for the startup and low-load conditions. The higher travels of the cage use larger drilled holes or windows to provide the flow rates needed for normal operation. If a single valve is used, the DP between the pump discharge and drum needs to be monitored by the control system. An interlock in the control system should be established to prevent the valve from opening past the anti-cavitation portion of the trim until a non-cavitating DP is reached in the system. This example shows valve stage operation limited by drum pressure. As drum pressure rises, additional valve stages will allow increased water flow. At the same time, as differential pressure across the valve drops, its position will increase as allowed by the drum pressure. This will prevent cavitation throughout valve operation. The safety valves are a special valve required by boiler code that are used for pressure protection. Their sole function is to prevent a system from going above a preset design pressure and potentially causing failure of that system. As part of maintaining proper water chemistry in the HRSG, chemicals are added to control parameters such as pH, dissolved O2, and others. As water turns to steam, these chemicals drop out, stay in the water, and can reach undesirable levels. The purpose of the continuous blowdown valve is to remove those impurities from the system. This is a harsh service due to the impurities including rust, scale, and excess chemicals that also flash to steam between the drum and the flash tank. Steam temperature is controlled using an attemperating system. It consists of a desuperheater, spray water valve, spray water block valve, and a strainer. The control system measures the temperature of the steam, compares it to set point, and then increases or decreases the spray water accordingly to maintain temperature set point. The desuperheater can be a ring or insertion style depending upon the water flow requirements. The spring-loaded nozzles in the desuperheater have relatively small passages, and it is recommended that a strainer of suitable size for the nozzles be installed in the spray water line to prevent nozzle plugging. It is important that the spray water and block valve shut off tightly so that water does not leak into the steam line when it is not required, causing potential damage from thermal shock or efficiency losses from operating below steam temperature set point. Startup vent valves, also called sky vents, are used during plant startup. The valves regulate the temperature of the HRSG steam system to ensure proper warm-up of the system. The stop-check valve is used in power plants for safe operation of a HRSG. If a HRSG is offline or trips, the stop-check prevents the higher pressure from operating units to backflow into the offline HRSG. It combines the performance of an isolation and check valve into one unit. A stop check has its stem disconnected from the plug. Therefore, when it is open, it works as a lift check with a freely moving plug. In forward flow, the plug will remain open. In reverse flow, the plug will slam closed, preventing backflow. A stop check valve is required by boiler code when two or more boilers are connected to a common header for safety, but should not be relied upon as the primary shutoff valve. The main steam stop valve's primary function is to ensure tight bidirectional shutoff to the main steam line and is required by boiler code. During a plant shutdown, steam production is gradually reduced and ultimately stopped. At the same time, feedwater flow is reduced and ceases once steam production ends, maintaining drum level at its set point. When feedwater flow rate is reduced below 30%, the boiler feedwater pump recirculation valve opens to maintain required cooling flow through the pump. At proper shutdown drum levels, the boiler feedwater pump is secured and the steam drums are bottled up in preparation for the next start. If shutting down for an outage, the vents and drains will be opened to remove all water from the HRSG.